anything bad happened to you, right? Yeah. I know. Look at me. Look at me. Look at me. Look at me. Do I seem scared? No. Yeah. But I get it. Yeah, I was definitely scared of thunderstorms when I was a kid too. Yeah. Hey, look at me for a second. I know it's scary. Oh, I know. Do you want to play the eye contact game real quick? No? Yes? Okay, we'll do a quick eye contact game. Let's see if we can do. What do you think? 5 seconds? I bet we can do 5 seconds. Okay, ready? And let's close our eyes right there. And 3, 2, 1, go. 1, 2, 3, 4, 5. Good job. You did it. Okay, you can look away. I know. That was really impressive. Do you think? No, you couldn't. You couldn't do 10 seconds, could you? I mean, that's a lot. That's a lot of seconds. That's how many hands, how many fingers you have. It's 10. That's a lot. Can you try? Okay. That's right. We're gonna try. Okay. Prepare ourselves. Look away. Look away. Look away. Alright. Don't look at me yet. Don't look at me yet. Don't look at me yet. Okay? I gotta prepare myself for this. I gotta, hey, it's too much. Let me prepare okay. We're gonna cover our eyes, and when we open our eyes, we're gonna look at each other for 10 seconds. Okay, ready? Okay, let's close our eyes. And go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Look away. Wow. That is truly impressive. Wow. Whew. Wow. I mean, I'm feeling a little better, are you? A little bit. Yeah. Where does lightning and thunder come from? That is a great and powerful question. I will do my best to answer this. I may have to Google some of these facts later. But, your grandpa was, and still is, he's a generally, like, really, really smart dude. You want your thunder buddy? Sure, you can have your thunder buddy. What? Which one do we want? We want Miss Mittens. So we got Miss Mittens. She could be our thunder buddy. Yeah. We got Miss Mittens. Put her right here. Right there with Miss Mittens. And then we have, stay. She's got, okay. We have Mr. Mittens. Mr. Mittens. Mwah. Mr. Mittens. I know. I like Mr. Mittens too. So Miss Mittens and Mr. Mittens. And let's see if I can get them to stand up and just chill. How about like there? Oh, stay there. Kind of. They're struggling. It's hard. Stay focused. Okay. I don't know. Close enough. Anyway. Or do we want Senior Snufflepuffles? This is a tough call. Senior Snufflepuffles. Oof. Senior Snufflepuffles. He is a force to be reckoned with. So, I mean, if we need to bring in the big guys in Senior Flufferpuffers, then, if that's what we need, then we can bring in Senior Flufferpuffers. Yeah, all three. Okay, alright, we're doing all three. Miss Mittens. Mr. Mittens. And Senior Snufflepuffles.
Hey, hi there. Hello. You're so brave.
Okay. So, where do these things come from? Lightning and the thunder. Well, according to your grandpa, if I can recall these facts to the best of my ability, well, let me tell you some things about some thoughts before they knew what lightning and thunder was. The ancient Greeks, you know about the Greeks? Yeah, that's right. They have all those really cool temples with the columns, yeah, and those great stories about, Zeus and Hermes and Achilles and Hades and Hera, Zeus's wife, and Aphrodite, and right, all those amazing stories, Sisyphus, yeah, all those great stories, right? Well, the Greeks thought that lightning was Zeus up on Mount Olympus, throwing boulders around and generally creating a ruckus. I mean, can you imagine some big, strapping, shirtless man with a big head of white hair and a big, massive beard up there throwing boulders or lightning bolts down from the mountain? Well, it's a very cool story. Turns out it's not true at all, but it's a cool story. Another story I was told from like a cousin or something was that thunder and lightning is when the angels in heaven are bowling, and when you get a big boom of thunder, that means one of the angels got a strike. Yeah, that's fun too. But it's not true, despite how fun it sounds. I like the idea, but that's not actually what thunder and lightning are. So, do you know about... Okay, you know how if you are wearing your rubber shoes and you scuff your feet on the carpet, right? You walk around and you go up to a door, or me, or your mom, or anybody, but especially like a metal door handle, and you reach out and you try to touch it, and you get that zap, right? Okay, well, that's called a static electric discharge, which is basically the same thing as lightning, just on a very, 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 very small scale. So, what lightning is when you have the surface temperature of the earth is warm, and there's moisture up in the sky. It's like humid, okay? If it's too dry, clouds won't form, but if there's moisture in the air, and you have a warm surface temperature, hot air rises. That's right, very good. You're very smart. So the hot air is rising. if you get really moist air, humid air, and really hot surface temperatures, you can get this really big cycling, and all this hot, warm air starts lifting up this water, and it starts to freeze and make little ice crystals. And what's happening is when you get those really big thunderheads, is you have all this turbulence. The warm air is coming up and lifting the water droplets and the ice crystals up, and then they're getting charged because when your feet shuffle on the floor, you're picking up, you're collecting electrons. And an electron is a negatively charged particle, okay? And as you collect those, the thing about electricity is it wants to keep moving. And the word static means not moving, right? So it's like it's not moving. Static electricity. And so it wants to escape those when you touch the metal doorknob, right? Or anybody, your friend or whatever, it releases, right? Well, the same thing is happening with a cloud. The warm air is lifting these droplets of water, all these molecules up, and they're collecting these protons, which are positively charged particles. So you get these positive particles at the top of the cloud, but once it gets to the top of the cloud, eventually it gets too cold and the air can't keep rising. So what do you think it does? Exactly. It falls back down through the cloud, and as it's falling down, those particles and those ice bits and hail and rain, as they're coming down, they're collecting electrons. And so what happens is the bottom of the cloud is negatively charged, and the top of the cloud has a positive charge. And if you get enough of that static electricity, eventually you get a lightning bolt. And most lightning happens up in the clouds, right? Most of it. And obviously, you and I aren't really afraid of that because it's up in the clouds. Fair enough. But what happens when lightning goes from the cloud to the ground? Well, what happens is you get a lot of, just like your feet rubbing on the carpet, those molecules are spinning around and they're rubbing and making friction. And when you get enough of a negative charge on the bottom of a cloud, a big thundercloud, it wants to release. And what it is the surface of the earth generally has a positive charge. And what it's trying to do is find the path of least resistance. The path of least resistance. So, it's looking for the high point on the ground, which is why things like steeples, right, flagpoles, telephone poles, generally speaking, the highest thing above the surface of the earth, that's where the lightning wants to go. Because in a way, you can kind of view it as like, I mean, it's fundamentally lazy, okay? It's not going to do extra work it doesn't have to do. All it wants is to get from the cloud to the ground or someplace else with the path of least resistance. So, if you are ever outside during a thunderstorm and you're in a field, would it be a good idea to go under a great big tree? No, that would not be wise. little fun fact. What the lightning actually does when it's trying to do a lightning strike with the ground is at first, and this happens so fast, you can't even see it. It first sends out these like little feelers called stepped leaders. And these little feelers go out ahead of the lightning strike, and they're feeling around on the ground for the highest point, the path of least resistance. And the positive charge from the ground kind of does the same thing, and it actually connects from the ground up. And when they reach each other, it's like that famous painting of Michelangelo where God and David touch fingers, and one's going this way and they touch, and that creates the lightning bolt. But that is not where the thunder comes from. The thunder comes from the air being superheated in an instant. To get this, how hot do you think a lightning bolt is? Do you think it's more than 500 degrees? It's way more than 500 degrees. Is it more than 1,000 degrees? It's way more than 1,000 degrees. A lightning bolt can hit 54,000 degrees Fahrenheit. That's very hot. That's so hot that that's roughly 5 times the surface temperature of the sun. And you know how when you go outside and you feel all the heat from the sun on a warm day, well, that sun's a very, very long way away, and that sun is at about 10,000 degrees Fahrenheit. Well, a lightning bolt can reach 54,000 degrees. What that does to the air is it basically temporarily sears it. So, what happens when things get superheated? That's right, they expand. And so as that little tiny, tiny sliver of electricity is going down, creating that 54,000 degree thread, it is ripping apart the expanding the air. The water molecules and all the molecules are being hyper expanded super fast, and that's what creates that, followed by that is the lightning, followed by the thunder. I know. Do you think you're going to remember all that? Well, ask me again sometimes. I'll tell you more about it. Oh, another fun fact. My dad taught me this too. Okay, hold up your hand. Okay. How many fingers do you have on a hand? 1, 2, 3, 4, 5 fingers. Right, we have 5 fingers. Well, it turns out that sound travels at about 5 seconds per mile. Okay? It's like 340 meters per second or something, I don't know. But it's about every 5 seconds, so 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000 is the time it takes for sound to travel 1 mile. Now, light travels way faster than that. Okay? I'm blanking on how fast, but it's like 23,000 or 230,000 kilometers per second. I forget. It's very fast. But for example, okay, when the light leaves the sun, it takes about 8 minutes for it to hit us here on Earth, okay? So you're seeing it delayed by about 8 minutes, but that's here to the sun. It's a long ways away, okay? Every 5 seconds is about 1 mile of sound travel. So, if you see a flash of lightning, start counting. Count 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000. Boom! If you hear the thunder at 5 seconds, how far away was it? 1 mile. Very good. What if you counted to 10 Mississippis? 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi, 6 Mississippi, 7 Mississippi, 8 Mississippi, 9 Mississippi, 10 Mississippi. How far away would that be? 2 miles away. Very, very good. Okay? Exactly. So 1 hand, 5 seconds is 1 mile, right? You can do 1,000 or Mississippis. They're both pretty accurate, relatively speaking. But yeah, that's how you can tell how far away a lightning strike was. So what if you only got to like 2.25, 2.5 Mississippis? So you see the flash, and then you count 1 Mississippi, 2 Mississippi, boom! How far away was the lightning? Very good. About a half mile. That's right. So that's not very far away. Yeah. Now the guideline is the 30 for 30 rule, which is if you see a flash of lightning and you start counting, if you can get to 30 before hearing the thunder, you're probably okay. I mean, if the thunder sounds loud, you probably want to get indoors somewhere, someplace safe. But yeah. And then what you want to do with 30 for 30 is because then you want to wait 30 minutes. So if there's 30 seconds between the lightning and the thunder, followed by 30 minutes of no lightning or thunder, then it's probably safe to go outside. Yeah, the 30-30 rule. That's right. Yeah. I'm trying to think of any of the other cool lightning and thunder facts that I can teach you. Are you getting sleepy? Yeah. Well, like I said, the good news is lightning is pretty lazy. So, if you find yourself in a house or a car or any kind of structure, you're probably going to be safe. Yeah, because lightning really just wants to go around and get to the ground as quickly and as efficiently as possible. Yeah, typically where people get struck are like golf courses where they're out, taking a chance, and they're swinging a metal club up into the air, which the lightning views that metal club as like a very tiny lightning rod, and it's looking down from the cloud, and it goes, oh, look, there's a little piece of metal I can react with. And that's how a lot of people get struck by lightning. So, it can be avoided. Yeah. And where it gets risky, though, is if you get up in the mountains. Your uncle was telling me this one time. he was climbing up in Colorado, up Pikes Peak, which is a famous mountain. And there's a famous area called the Boulder Field. And lo and behold, he got caught in a kind of like a flash mountain storm. They can happen really, really quickly. And so he hunkers down in these rocks, and the boulders go way above his head, and you could hear thunder like booming all around him. And like he said, it looked like the rocks above him were almost literally glowing. Yeah, that's pretty intense. No, he was fundamentally safe, because he tucked, these are huge, big boulders, and he tucked himself down, you know, as low to the ground as he could get, and he just waited it out. Yeah, he was fine. Just like you're fine, aren't you? Yeah. Well, does it feel a little less scary now that you know kind of what it is? Maybe, maybe not. Well, it should be over soon. Yeah, get some rest. Just let yourself close your eyes. And maybe it's easier just to